There's a video clip that's been quietly circulating among exhausted parents, sleep consultants, and pediatric nurses for years. It doesn't look like much, just a simple, repeating animation made by NASA. No music, no voices, just a slow, pulsing loop. And yet, babies who wouldn't stop screaming suddenly go still. Their fists uncurl, their eyes glaze over. Within seconds, they're calm. People called it the NASA baby hack. Sleep-deprived moms shared it in Facebook groups at 3 a.m. Nurses played it in NICUs. Pediatricians started mentioning it to new parents. But almost nobody actually explained why it works. Today, we're going to. Let's start at the beginning. What is this GIF? It's a looping animation created using data from NASA's Solar Dynamics Observatory, or SDO. The SDO is a spacecraft launched in 2010 that orbits Earth and photographs the sun in extreme ultraviolet light, wavelengths invisible to the human eye. The images it captures are then colorized so that scientists can study solar activity, plasma loops, solar flares, magnetic field lines. When you slow those images down and loop them, you get something mesmerizing. The sun pulses. It breathes. Its surface ripples in slow, rhythmic waves. And that rhythm, it turns out, does something extraordinary to the newborn brain. Now here's where the neuroscience gets fascinating. A baby's brain is not a smaller version of an adult brain. It's a fundamentally different operating system. Newborns are born in a state of sensory overwhelm. Everything, light, sound, touch, hunger, temperature, hits them without any filtering whatsoever. They haven't yet developed the neural architecture to sort signals, suppress distractions, or regulate their own arousal. That's why they cry. Crying is the only tool they have. But here's what researchers discovered. There are specific types of visual stimuli that can actually hijack the baby's attention system in a way that overrides the distress response. Think of it like a circuit breaker. When a baby is crying, they're in a feedback loop. Distress triggers more arousal, which triggers more crying, which triggers more distress. To break that loop, you need something powerful enough to pull the brain's limited attention resources away from the internal distress signal. And it turns out, slowly pulsing high-contrast visual stimuli are among the most powerful attention grabbers the newborn nervous system has ever encountered. The NASA Sun GIF checks every single box. First, contrast. The animation is dark space, almost pure black, surrounding a brilliantly glowing golden orb. Newborns are born nearly colorblind. Their visual acuity is around 2400, meaning they can really only see clearly within about 12 inches, but they are exquisitely sensitive to luminance contrast, the difference between light and dark. That glowing sun against black space is, from a newborn's visual perspective, one of the most compelling things they could possibly look at. Second, slow, predictable movement. The solar footage loops slowly. The plasma on the surface moves in gradual, rhythmic waves. This is critical. Fast, jerky, or unpredictable motion doesn't just fail to calm babies, it can actually escalate their distress. But slow, cyclical movement does something very different. It activates a primitive visual tracking mechanism that exists even in premature infants. The eyes begin to follow, and when the eyes are tracking, the brain is engaged, which means it's not processing distress signals at the same intensity. Third, the loop itself. The GIF never ends. It never changes. It repeats in a perfectly consistent cycle. And repetition, reliable, predictable repetition, is one of the most profound calming cues for a dysregulated nervous system at any age. It's why rocking works, it's why heartbeat sounds work, it's why white noise works. Rhythm signals safety. It tells the nervous system, the world is predictable. You are not in danger. Fourth, the lack of a face. This one surprises people. Babies are hardwired to seek out and lock onto human faces. There's an entire dedicated neural module for face detection that activates at birth. But faces are also sources of enormous emotional information. A tired face, an anxious face, a tense jaw, babies read all of it. When a crying baby is held by a frantic parent, the baby detects the parent's stress and escalates. The NASA GIF has no face. It has no human emotional content whatsoever. It is, in the best possible way, completely neutral. Pure, ancient, cosmic pattern.
Now let's talk about what's actually happening in the brain during those first few seconds when the GIF works. The visual signal from the sun enters through the retina and travels to the primary visual cortex at the back of the brain. But simultaneously, it routes through a structure called the superior colliculus, an ancient part of the brain that exists in basically every vertebrate species on Earth. The superior colliculus is responsible for orienting attention. It's the reason both you and your cat snap your heads towards sudden movement. In babies, it's extremely active, and it responds powerfully to that slowly pulsing high-contrast sphere. When the superior colliculus locks onto the stimulus, it triggers a cascade. Norepinephrine, a neurotransmitter associated with alertness and arousal, shifts its pattern of release. The default mode network, which is associated with internally directed processing, like, say, registering hunger or discomfort, gets partially suppressed. Meanwhile, dopaminergic circuits associated with visual reward get activated. The baby isn't just distracted, their brain chemistry is actively shifting. And here's the critical detail. Crying is metabolically expensive. It requires coordinated muscular activity across the face, diaphragm, and lungs. It takes effort. The moment the brain's attentional resources get redirected, genuinely redirected, not just briefly interrupted, the motor program for crying starts to compete for resources it can no longer fully access. The cry weakens, the breathing slows, the muscles relax. And once the baby has been in that calmer physiological state for even 30 to 60 seconds, the feedback loop breaks. Re-regulation becomes possible. Now, some parents have asked, is it specifically the NASA sun footage, or would other slow, looping, high-contrast visuals work too? The honest answer is, other stimuli can work, but the sun footage has an unusual combination of properties that make it almost uniquely effective. The round shape matters. Circles are among the first forms babies can actually perceive clearly, and they trigger tracking better than irregular shapes. The golden color, while babies can't see it richly, falls in the luminance range that registers most strongly against a dark background. And the specific speed of the solar plasma, which happens to move at roughly the pace of a slow breath, may align with what some researchers call respiratory entrainment, where the observer's own breathing subtly synchronizes with a rhythmic visual stimulus. There's also something to be said about the scale of it. Parents often report that watching the GIF alongside their baby, in those desperate, silent 3 a.m. moments, is calming for them too. You're watching the sun, the actual sun, something 4.5 billion years old, a star 109 times the diameter of Earth, doing what it has always done, completely indifferent to the chaos of your living room. There's a perspective shift that happens almost involuntarily, and a calmer parent, as we already established, produces a calmer baby. The science, the wonder, the cosmic scale of it, all of it compressed into a silent loop that your phone can pull up in under 3 seconds. The universe, it turns out, is a pretty good babysitter.